Welcome to a tutorial in IronCAD using a model from Toby dated 5/1. This is a sheet metal cover plate, so we'll design this in our sheet metal in IronCAD. And basically this model has a lot of dimensions that you have to kind of backtrack to get, but it's really kind of a symmetrical part. So you kind of build one half of this model, mirror it over, or symmetrical shape on the other side. Then you can add your bend features with the relevant information on those. So we have some information about where these offsets are, how wide this geometry is, and some reference locations from like this offset from this bottom of this face gives this location for this curve here, and we know some key constraints to how wide this is, how wide these little flanges or these lengths are here, and some offsets inside of this. So it's not too awful complex. We do know the sheet metal is a 3 wall thickness sheet metal, and we have a bend radius of 3 millimeter as well in these cases on the corners and things. So what we'll do is we'll hop over to IronCAD and we'll go ahead and build this model. So in IronCAD, if you're in our starter catalog, there is a sheet metal catalog here. You can also go to more catalogs and go directly to the sheet metal catalog, but you can just directly go into here. And so what we're going to first do is drop out of stock, and it doesn't really matter. I'm not going to pick actually any particular stock here. I'm just going to select one, and then I'm going to right click and go to the part properties, and I'm going to change the thickness and minimum bend radius there. So we know it has a thickness of 3 and a minimum radius of 3 as well. So that's our starting point for our model. So next, most of this is done in the sketch. We don't really have good ways to design the shape with all these constraints that they place on this one specifically. IronCAD's handles work really well for in-place design, so you can refer to and snap to existing geometry, whether they're size box or these curve handles. But we'll show you how to do this in the cross section as well. So we're just going to edit the cross section. In this case, we're just going to select everything and get rid of it to start off with. So what I'm going to do is basically kind of start with the overall outline of this geometry, and we can just start with a polyline, for example. And we're just going to start somewhere up here, and you can see on the left it's giving you some coordinates where you're at in space on here, so it doesn't really matter too much for us. We're just going to draw our line out here, some sort of angle. We're going to go up. This is going to be a 10 value. We're going to do our 50, go back down, align to this. And all these dimensions that you see, I'll show you what those are in just a second. So we're just going to draw this down. We've got an angle shape here. It's going to come up. It should be horizontal, by the way. Come up, and we're going to come over and go down. I'm just going to leave it at the line here at the down line. So a couple things here. I didn't draw this horizontal, so I'm just going to pull these over to make these horizontal and vertical inside of here to get a starting point for our geometry. And we can adjust this stuff around at any point in time afterwards. So what we're going to do is use this starting point and put some dimensions on here to drive it. So we know, for example, we know how far this is offset here, which is a 120, and we know this curve is actually, we want to do the curve here, so let me zoom in a little bit, get the curve here, and we're going to set that to 50 to move that over in there. We also know the angles here. We know this has an angle of 40. We're just going to put that at, this is an angle of 80, so it's going to be a 40-degree angle there, and this angle for this shape it's got an angle of 40 at the bottom, so that one's going to be a 20-degree angle there. So again, if I want to make these constraints to maintain this, I can just lock these down. So make this one vertical all the time. I can lock that as well. So make sure that those maintain. Some other things we know the dimension from here to here. So we'll go ahead and put that dimension as well down here to the bottom of this. We can just pull it off, and we know that's at a 115 inside of there. So this doesn't move anything around, so we can just pull these up inside of here and adjust these however we need in our model. So we can just move these around. We can pull these up to give us some more clearance and some more space in here just to see what we're working with. So this is kind of our starting point for our model. And why I left this model length down here is because it's actually defined, this line is actually defined 10 millimeters from this offset curve. So there's an offset there, then this is driven from there a certain distance. We can draw the line in there. I'll just kind of walk back through this. So a couple other things we do know, these two curves are actually 10 millimeters as well. So let's go ahead and put those on there as 10 millimeters for that. And this is 10 millimeters as well to drive those up. So now we've got that set, we can do some other things. So the other things that they're using is offsets. So we'll go ahead and offset some curves. So for example, this curve at the top, we're going to go ahead and offset that, and it's got a value of 20 inside of here. We're not going to use any constraints. We're just going to offset these curves and get an idea where they're going. So this one's going in the wrong direction. So let's just flip that down to get that to go down 20 millimeters from the top edge there. These two are offset 10 millimeters, so we'll just go ahead and select both of those curves and go ahead and offset those 10 millimeters inside of there, and they're already going in the right direction, so we'll go ahead and hit OK. And then last, we're going to offset this one, which has got an offset of 45, I believe. So let me just double check that. Yeah, 45 millimeters for that to give that bottom curve there. And what we're mentioning is this line here, this bottom curve here, is actually 10 millimeters from there. So I'll show you a couple ways to do that. We can do one is we can just offset this curve again. There's a simple way to do it. Just offset 10 millimeters again down, so we know that's where this curve needs to be aligned to this geometry. So one thing we can do is just simply pull that up until it aligns, so we know that's 10 millimeters from that edge. Okay. And now what we can do is just do the extending and trimming on this geometry. So let's go ahead and extend this so we can see where it's extending to, and if you hit the tab key, it'll extend over to the next line in the path, which is where we want it to go. Extend that one down, then we just have a series of trims here, so we'll just go ahead and trim, and we'll just trim off this extra geometry inside of here, so we don't need any of this geometry out here. And just walking around, trimming that off, and we really don't need these two curves either. So we'll just get rid of that geometry, and we have that basis for our geometry. So this is kind of the starting point here, and so now I'm going to go ahead and select this, do a fillet on it. So I've double click to select all of those curves in the chain, and then I'm just going to select a vertice and just drag. And when I right click, I can type in the value for that, which is 4 millimeters. So we can just do all those at once to apply that. So now we have some other information that we need to know. Okay, a couple things. We know that this curve, so I'm going to turn off some of these things. So you see is curve dimensions, and we have see endpoint dimensions. So this is telling us the endpoint dimensions of where these curves are. From the reference is usually the XY axis here, so we know how far this line is out from that, or you can pick on one of these lines to get that as well, to see how far it is from that line. In this case, the furthest distance is 104 total width between the lines, so that's just half of that, so that's going to be 52 for that. So that's just going to move that line over 52 millimeters. So we've got this one essentially sitting 52 from our center point reference. We also know that this curve needs to be a distance from here, total of, let's see, 30 from this top curve. So what we can do is just essentially move this reference line up here, and now it's telling us where this curve is. We can change this to 30, and that will drive that curve up. So that gives us basically that distance of 30. We've got this one set, and we can also go ahead and set the distance for this curve, which is a total of 52, so that's going to be 26 for that one to define that. Now we can define how long this one needs to be. From here to there is 40. So again, we can just do essentially, I believe that's total of 40. So we can just do an offset here of 40 for that curve. That'll place it there. And again, we can just do our trim to get that off. So that basically will give us our profile geometry for everything in place. Again, so this is our 52 from there, which gives us a total of 104. This one reference here is 26, which gives us the 52 inside of there. Again, this one, if we pull this line up here, we can refer to that as 40 inside of there, so we know what that reference is. We select this one, we know it's 30 from there, and if we want to know that, it's 10 millimeters. So that's just a way to do it without doing a lot of constraint dimensions. So we have a lot of curve dimensions in our sketch, so it's really kind of handy to use those to move curves around, and you don't have to have the constraints. I just put some on here to show you. You could have done the same thing with our curve dimensions because they're all on there. We can move these around that way, but I do some on there just so visually I can see some references, key references that I want to make sure that I can see those easily. The rest of them I know they're spaced correctly, nothing's going to move on this, so I'm good to go at that point. So now I can just go ahead and do a select all of all this, which is just your standard Control A to select all that, and we're going to mirror that to the other side, and we're going to use our curve there, center curve, our y-axis, as the mirror plane. So now we've got our geometry to the other side inside of there, and next we can just draw our other element inside of here, which is a rectangle. In our case, it's going to be on the center of this guy, and we know the width and the height of that already. So we know the width of this guy is a total of, let's see, 36 width, and the height of that is going to be the 40 minus the 8, so 24 for the height of that that curve there. And then we can select it again by double clicking and do the fillet on that one, because it also does have 4 millimeter on that as well. So that kind of gives us our base shape here for our model. So then we go ahead and hit finish, and that will give us our stock base profile. Next, we can do some bends on this geometry. So we know these are the overall reference that we want. So, again, so we can look at this by selecting the curves. We know that total distance is the 115 there. So we want to maintain that. We don't want to adjust that. So what we're going to use is we have a series of bends in our sheet metal. We have a regular bend, end bend, and out bend. So we want to maintain this outer edge. We're going to use an out bend and drag and drop that onto that sheet metal. So it'll maintain that edge and move the geometry in to give us our bend. Next, we just need to set our height. So we're going to set our height from the bottom edge of this, which in this case is 18 for this one, which is the 12 plus the 6 millimeter radius, which we'll show you in just a second. So we've got that shape, and then we'll go ahead and put a profile here. They have a 6 millimeter through hole on there, so we'll go ahead and put that on there as well. Next, we want to put the other bend here. And now in this case, we want to keep this edge because this is a total distance. If we select these two edges here, these edges are set to be 104. We want to maintain those and add material to it. So in that case, we will just use the regular bend and drop that on to this edge. And we do know that this overall length in this case is actually 34. So we'll just double click that, set that to 34. Inside of there, and we can do it the same thing, edit distance from here to select this to adjust it. But another way to do that is to double click on these, and you have a series of different ways to measure that. So you can use to the end of the bend, sharp corners, bend length to the flange length inside of there. So inside sharp, you can use these things. In our case, we want to know that the total length of that curve is going to be 20 in this case, and we can set that. So it's the same again as you could have done this, edit from point, select that, it's going to give you the 20. So either way, you can do it. I just wanted to show you a couple different ways to achieve that. Next, we have the slot feature, so we can drop one of our standard slot features on here, but we also have cut features in here. These are kind of nice as well, that this one drops in some orientation here, but we're going to just rotate this around so that it's parallel to that. And then we can go into our tooling features by right-clicking on this and going to tooling features, and we can set the height or the actual value of this, which is going to be 20 millimeters because it's offset 10 millimeters from the centers on each end of that, and we have a 6 thickness, so the radius is a 3, so that's why it's 20 millimeter inside of there, and hit OK to adjust that shape. And again, we can position this object inside of here if we want to position this, and we know this actually has a height value. Just to do it here, we can just edit from distance from point. From here is actually 12 from there, so we can move that down a little bit. So it's not actually on the center of that face. So we can do that as well inside of there. Next, we'll go ahead and mirror these to the other side. And so we'll just go ahead and we can select these by holding our Shift key down, selecting all the features that we're going to mirror, which are those 2 bends and the features. And we'll use the mirror feature, and we'll say to about this point. And go ahead and hit OK to do that. So now we've got those created there. The last thing we need to do is some fillets on this. So you could use our regular fillet or blend tool to do these edges, but we also have a nice sheet metal tool here for corner breaks, which can apply blends or chamfers. So we have one that needs to be 6 millimeters for this, and you can do the entire part, which would also get some of these other things on here, like these corners, which we don't want. So we're just going to pick the desired geometry. So in our case, we're just going to pick these points that we want. We're just going to move our cursor around to pick the points that we want to apply those. So that one there, these here as well. And as we're walking around, we're going to get these inside ones as well. So we want some selective locations that we want to have that 6 millimeter fillet on, and then hit OK, and we can get that. Okay, so those are nice little fillet features that we can add to this thing. Next, we can go into our properties, and in this case, it has a mass density of 7,800 on this, and that should give us a 292.5 grams in this model. So since it's a sheet metal, just to kind of show you this, you can unfold it flat just to see that, and you have your bend lines and everything that you can take into the drawing to dimension the flat drawing and the folded drawing together for these models. Fairly easy to do in IronCAD. So this is just one of the sheet metal parts, but again, you can do a lot of modifications to these. We have part handles on here, so you can adjust certain locations of your bend. So if you wanted to, for example, extend this out, you can easily do that inside of here without even going into the sketch modes to do that. So that's just some things that we do have on our handles. They're all available here that you can modify all these curves independently. So I can select these to move and adjust, like maybe this could be a different height than that one, easily to do it outside of the sketch with our handles. So just some things we wanted to highlight inside of our IronCAD design with our handles and sheet metal. So hopefully you enjoyed this presentation on IronCAD using sheet metal from Two Tall Toby's models. Thanks.